Now we're going to up the ante even more and put a second substituent on the cyclohexane ring and see what the consequences are of doing this. So if we want to make something like 1,2-dimethyl cyclohexane, that means that we're putting methyl groups on adjacent carbons. There are really two ways you can do this. You can put them both on the same side of the ring, as we see here, and this is called a cis geometry. Or you can put them both on opposite sides of the ring, and this is called a trans geometry. Hopefully you read through some of the module and you've done reading in the book, and you know that this is a type of what we call stereoisomerism, where the connectivity is the same, so you can't say that they're constitutional isomers, but since their orientation in space is different, we call these stereoisomers. So let's take a closer look at the cis 1,2-dimethyl cyclohexane. What you have here in both of these pictures are the methyl groups at the 1 and 2 positions, so on adjacent carbons, and they are in the cis orientation. They're both on the same side of the ring. However, you're looking at two different chair forms. So this is the cis 1,2 interconverting between chair 1 and chair 2. Notice that in chair 1 you have one axial methyl group and one equatorial methyl group. And in chair 2, of course, they interconvert. Whatever's axial becomes equatorial and whatever's equatorial becomes axial. We learned in the last video that it's thermodynamically preferable to place substituents in the equatorial position because it eliminates gauche interactions. However, in this case, no matter which chair form it's in, chair 1 or chair 2, you have one substituent that must occupy the axial position. And so there's really no preferred chair in this case. And at equilibrium, you would have a 50-50 distribution of the two chairs. However, when you look at the trans isomer, so again, we have 1,2 and 1,2, notice that the trans, you have in one chair, both of them axial, and in the other chair, both are equatorial. So it turns out that in the case of trans, there is a clear preference for this chair that's on the right that I'm calling chair 2. And so you would have the majority, I don't know the percentage of this, but you'd have the majority of the chair, maybe even close to 100% of the chair form that puts both substituents in the equatorial position.